All right, for those of you listening at home, hello Jonah, hello Emma. Well, actually, you'll be listening at home. You're not at home yet, so we're praying for you. Here is problem number 10, which, like a silly person, I chose and didn't have an answer in here. We're going to do this on the board. X equals sine of y. How on earth do you handle that? What does it even look like? Well, at least theoretically last year, I don't know, did you cover something called inverse functions? Did you play with those at all?
Yeah, like the sine of -1, or the,
Yeah, those are inverse sine, inverse cosine, inverse tangent. Now, you can get an inverse of any function whatsoever, and there's a trick to it. For example, if you have like f of x equals x squared, that one you might be able to do in your head. What's the inverse function of squaring? Square rooted, right. So at least in theory, when you write this, the inverse function of x should be, theoretically, plus or minus square root of x. At least off the top of your head. But how to get it in general, like if I give you something awkward like this, 3x plus 5 over 2, and I want the inverse, well, I don't know, how do you do that? The trick to getting an inverse function is you take x and y and trade places, physically. Like the input becomes the output and the output becomes the input. That's actually what an inverse is. That means it goes in reverse. So, what's another name for g of x? Y. To get an inverse function, switch the x and y. It becomes x equals 3y plus 5 over 2. And then, if possible, get y by itself, which is possible. I'm going to multiply by 2. I'm going to subtract 5. And then I'm going to divide both sides by 3. And presto changeo, there's the inverse function. Does that make sense?
Yeah.
So if you swap the x and y, you're looking at an inverse function. Why do I bring that up? Guess what somebody did before we got to the problem? They took the inverse of something. Y equals sine of x is something we've seen a lot. I mean, not every day, but we know how to graph that. Like y equals sine of x looks like this. It starts at the baseline, the height of 0. You count by pi over 2's. Pi over 2, pi, 3 pi over 2, 2 pi. And it goes to the max, base, min, base. And it keeps going, of course. You can go to negative pi over 2 if you want to go crazy. And it keeps going. Okay. Now, what does this graph look like? There are two ways to get an inverse graph. One is to change the formula, swap the x's and y's out. The other, which is actually totally sneaky, to get any inverse, you trade all the x's and y's. That also works with the points. This point, attack my I developed this reflex of don't get ink on your laser. So, startle reflex. This is pi over 2 comma 1. If you want to graph the inverse of this function, go to 1 comma pi over 2. And this one is actually easy. This is 0, 0. So if you swap those, you get 0, 0. The next one is at pi comma 0. The inverse goes to 0 comma pi. And you might be able to get a little estimate of what it's going to do now. It'll eventually do this, 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 this. So we could graph it like this. There's actually a shorter way to do it even let's show you what it means. X equals 0. That is this. It's the y-axis. So I want a graph between these four curves. This is the curve x equals sine of y. This is the curve of x equals 0. I know it's not. It's a straight curve equation. In geometry, actually, is not nonsense. Y is equal to pi over 4. Because over here, if you did x equals pi over 4, it would be this vertical line. So over here, you have a horizontal line. Which again, makes sense with the inverses. When you take x equals pi over 4, all the x's are replaced with y's for an inverse. And then you go to 3 pi over 4. We can at least visually see what we're after now. We want the area under this curve going from pi over 4 to 3 pi over 4. This you can do in a calculator. Go ahead and grab a calculator. Now, technically, the area between two curves is between this and this, so it's the higher one minus the lower one. The lower one is just kind of boring. Interestingly enough, you know, when we've just been doing a regular old area under a curve, you know, like here's a parabola, and you're getting the area under the curve, how do you do that? Antiderivative. From what to what? From A to B. And let's just call this f of x. It would be f of x dx. We've been doing that for a while. I'm going to let you in on a secret. This is actually an area between two curves. You ever wonder why it just magically stops at the x-axis? Why doesn't it just keep going down forever? First of all, you get an infinite area every single time, which is awkward. But there's got to be some reason. Why does it just magically know where to stop? Because it's this. It's between two curves. The invisible 0 is always there. So if you don't put another function, it assumes it's 0. And it'll stop when the height is 0. Which is actually kind of neat. It stops before you're doing anything really dumb. So here, on your do f and int, so math 9. What formula would you type in? This is a little tricky. Normally, like when I was doing this, you just, on the y equals screen, you just do sine of x. Or when you're typing in the formula, you just do sine of x. What would you type in this time? Sine of y. You ignore the x. This is like in an alternate universe, if you like. This, the y equals, just means we're graphing it in our universe. You step into this alternate, bizarro, infinite universe, or inverse universe, x equals means you can graph stuff. So you can ignore that. So f and int, just sine of y, and you'll have to use the alpha key to get to y. Where is it? Oh, it's right over 1. Sine of y, comma. What letter are you using? Y. So I think with yours you have to put dy at the end. So, okay, y. For the old-fashioned ones, you just put comma y. Comma, from what to what? Yes. It looks like we should be going down or something like that, but we need the increase. So from pi over 4, and there's a pi key there. It's right above the that caret key, the hat. So pi divided by 4, comma, pi divided by 2. Close parentheses, hit enter. Oh, whoops. Sorry. That. 3 pi over 4. Okay, go for it. What do you get? 1.412. I got that too. So the area, oops.
I got
It's approximately only
negative
1.414, 2135,
negative
62.
versions of it.
That means you did that thing, I don't know. You just make it
Why,
positive.
so I always do this, I always end up getting negatives, like,
Let me look.
when I do the problems, and I don't know why.
Oh,
so it's like-
from pi over 4, the bottom is the start, the top is the ending.
Wait,
So you do-
We're going from pi over 4, put that on the bottom, and then 3 pi over 4 on the top.
oh,
Yeah, so if you do the integral backwards, it'll always give you a negative version. So, okay,
Okay.
question, is that a fraction?
um,
Try to convert to fraction, see what happens.
no,
No, it is not. Does anybody find that familiar?
Um,
Has anybody seen that before? 1.414, blah, 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 blah.
yeah, we saw it yesterday, I don't remember what problem.
Probably. There are three, first of all, according to this calculator, this is irrational. There is no fraction equal to it. Either that or the calculator is just dumb, which is not impossible. But there are three explanations for irrational numbers. One is it's some version of pi. Two is it's some version of the mystery number e. Three, it's some sort of root. Do me a favor, square it, just to see what happens. What do you get?
Square root of
2.
yeah, so it's,
1.414 is radical 2. By the way, you do not have, that's a potential extra graph question, by the way. If you can get the exact answer on this, that could be worth a little extra. But as far as the test goes, when it comes, all you have to do is give me the decimal for area between curves and area of the two curves. I will tell you specifically if you need to get it the exact area. Usually, like, unless you can convert it to fraction, you're not responsible for the exact answer. Unless you can do it by hand easily. This thing, no, not so much. You could do it by hand, it's not too horrible. But I promise to show you a shortcut.
yes.
Well, it's not exactly a shortcut, it's just a more comfortable way to do the problem. That has value. So like an hour doing something comfortable versus like 10 minutes of doing something agonizing, and, you know, which one do you want? Depends on your personality, I suppose. Look over here though. You know how I would have done that, here's the x equals 3 pi over 4. This is like the normal universe version, and this is the alternate universe version. Can anybody take a stab and guess as to what area the normal one would have given? Exactly the same. Why do I mention that?
So we just find the normal area.
If you want, this will give you the same area as y equals sine of x, y equals 0, x equals pi over 4, x equals 3 pi over 4. Identical area.
So
Now-
that x equals sine of y and y equals sine of x is always gonna be the same, right?
Well, if you're underneath it, yes.
Yeah.
I double checked to make sure, but if you have x equals sine of y, that's gonna be falling toward the y-axis to get the area. In real life, for y equals sine of x, it's gonna fall down to the x-axis. But either way, it's gonna hit an axis pretty quickly, and you get the exact same area.
So is that the same thing for all problems? So if we did like x equals cosine of y, would that be equal to y equals cosine of x?
Short answer, yes.
would that work for like the other problems we did before?
As a matter of fact, yes.
Yay.
So, on the test, if you find something that's in the alternate inverse universe with functions of y instead of functions of x, technically, you're doing kind of a fast one. You're sort of waving a magic wand and turning things into the inverse universe, which is really kind of an extreme way to solve a problem. But, excuse me, this math problem is a bit awkward. Let me step into a parallel universe in order to solve this easily, and then step back and give the answer. Wow. You figure that, how efficient is that? I don't know. But it's true. And by the way, if you type this into your calculator, same answer. there's already an X key, they don't have a Y key, you have to do alpha, blah, 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 blah. So you are welcome to use that trick if you wish. It should work all the time. Trying to think of any cases where it wouldn't. I can't think of any cases where it wouldn't. Just be aware that you are doing something rather dramatic when you do this. It's kind of like, I said, what did you do? I just switched the letter. It's a little like saying, what did you do? I just switched the universe. You what? Yeah, it just made the problem easier. Okay. Yeah, I do that all the time too. Wow. So, does that make sense? All right. So, questions on the first two? 3B or 9? And yes, you can do this with the trick. Yeah. If you look at number 3B, by the way, if you change that to x squared equals 2y, and x equals 2y minus 2, and get y by itself for both times, you can do the alternate universe version, which is a lot easier to play with the calculator. Okay. Number 9, yeah. X equals y squared minus 4y. And there are a couple other things here. X equals 0, y equals 0, y equals 4.
So can you show how we can just flip this to the normal view?
Yes. If, basically, when you flip it, you're talking about taking the inverse, but you gotta take the inverse of everything. Not just one or two things, you gotta do it all or nothing. What does this one become? If you take the inverse function. Just trade the x's with the y's.
So just y equals x squared minus 4x.
Exactly. And then this becomes what?
Y equals 0.
Uh-huh.
And then x equals 0, x equals 4.
Right. This should look a little more familiar. You can actually factor this. That's y equals x parentheses x minus 4. That'll give you two roots. So you've got a root at 0 and a root at 4. And this is a parabola that is upward. So it's opening this way. And if you have two roots, do you remember where you can find the vertex and the axis of symmetry? If you have two roots, where would you look for it? Right smack dab in the middle. If this is 0 and this is 4, then yes, the axis of symmetry, which the vertex is on, is exactly in the middle at x equals 2. If the thing's opening up, would the vertex be below or would the vertex be above?
Below.
It's got to be below. How far below? Oh, people who remember your parabola patterns.
Well, parabola over 1 up 1, over 2 up 4. So, it could be negative
So
4.
somewhere down here, I'm going over 1 up 1, over 2 up 4. This is over 2. That means I had to go up how far? 4. Guess how far down the vertex is?
Negative 4.
Correct. It's down. It's 4 spaces down, so it's a negative 4. Ta-da! Congratulations. This is 2 comma negative 4. And you can graph a relatively nice parabola this way. And they wanted to go between y equals 0, which is this, x equals 0, which is this, and x equals 4, which is this. So basically they're asking for this. Notice anything funny about where the parabola is at that point? Height-wise?
4.
When I ask about the area under the curve, it's usually for things above the x-axis. This dips below. Anybody tell me what that's probably going to do to our area?
Negative.
It's going to register as negative, right? Which is actually kind of good. It's good that they flip it around and go negative rather than say, huh, you said go underneath it, I'm going underneath it, pew! And it'll be infinite forever and ever, well, boss, I had an infinite area. So I wanted to pave that thing. It got like $500 a square yard. Well, it's infinite. We can't do that. Well, it stinks to be you then. No, there's got to be an area of this thing. And we should be able to find it. So, take integral of this from 0 to 4 of x squared minus you could probably do it, by hand, but go ahead and type it in, it's a little faster. F of 9T, and then we catch up, x squared minus 4x, comma x, comma 0, comma 4. And don't be surprised if you get a negative answer.
Negative 10.666.
Yeah, convert to fraction.
32 over 3, negative 32.
Negative 32 over 3. You got it.
So on a test, would you want us to like mark that it's negative?
The question, if they're finding, sketch the region, find the area. If the thing is underneath, it's a little like, you remember where we were playing with speed versus velocity? Velocity can go forward or backward, positive or negative. Speed is always positive. How do you find speed?
Absolute value.
Absolute value. If you want to find area, there is no such thing technically as a negative area. So there is such a thing as a negative integral. But in real life, what's the real area of this thing?
32 over 3.
It's 32 over 3. The area is the absolute value. So yeah, you can just do multiple, mentally in your head. 32 over 3. Okay. That make sense? Any others? Everybody okay on 3B?
Well, can you say the answers to these?
Yeah, it is, I think it's 9 over 4. Yep, 9 over 4. And you can use the same flip the variable straight on that one. Well, I did not want to push too terribly far ahead, so I have for you, I have one new little topic, and then your assignment is going to be a worksheet, so you can use your phone or your computer you like. Ta-da. And Emma and Jonah, I'll email this to you. Unless you're next door or something, in which case I'll just sort of courier whatever to you.
Are they here?
I haven't the foggiest idea. I have no idea where you guys are, but we'll get it to you somehow. I'll email it to you just to be safe. One little catch. I want to find. Find this is a quick example, it's not from homework. Find the area enclosed between the following. Y equals, I'm going to do a normal universe problem here. Y equals, let's try x minus 2 parentheses squared. That's fine. Y equals x minus negative parentheses x minus 3 squared plus 4. X equals 1, x equals 5. Actually, no, x equals 6. First thing to do is figure out what this looks like. Grab a calculator. Go to the y equals screen and type in the formulas. Make sure there's a negative in front of the second one. So y1 is the parentheses x minus 2. What shape is that going to give us? Should be a parabola. Can you tell me where the vertex is right over?
2.
Yeah, 2 comma 0. Right, because they didn't raise it up enough. 2 comma 0. Where's the vertex in the next one? 3 comma
3. No, 4.
3 comma 4. It's in vertex form. So x minus 3 parentheses squared plus 4. Do not graph these. Your calculator doesn't know how to graph x equals 1, x equals 6. But go ahead and graph those first two graphs. Go to Zoom Standard if there's any problem. Now what I want to do is, let me see, 1, 2, 3, 4, 5. Actually, could you change something? Bring it back down to 5. I want to make this relatively small answer. Should be enough. So 1 to 5. Any idea how to do that? we've got a graph that looks a little like this. Over 2 spaces, over 1 up 1, over 2 up 4. Over 1 up 1, over 2 up 4. And then over here, we've got a 3, 4 thingy. Over 1, down 1. Over 2, down 4. We've got 1, 2, 3, 4, 5. Okay, this up just a little bit. From here to here. Something very weird is happening. What's making our problem complicated? I just want the area between 2 curves. We've done a lot. Just one minus the other one, right? What's different about this one? Let me highlight.
Well, it's not between like the two lines, there's extra. There's an
Yeah.
intersection.
Yeah, in other words, it's crossing itself. And not in the holy sign of the cross method. There's a teeny little snippet here, and then it intersects itself, then another blob looks like a distorted fish, and then another blob here. How on earth are we supposed to do this? If you were to take one minus the other, like if, let me show you which ones these are. This is y1 and this is y2. So the one that's going uphill is y1, this is y2. If all I were doing is the middle section, I would do y2 minus y1. And then just use the calculator to find the boundaries. And then ta-da. But if I do that here, this will register, have a look up here for a second. This will register positive. This is backward. This will register negative. Because the one that was on top is on the bottom. And it'll subtract backwards. And this will register as negative. We might get an answer of 0, which is not the area. Any other ideas of how to do that? I want the total positive area of all the shaded region up here. How am I supposed to do this if it keeps flip-flopping?
Can you do them all separately?
Exactly. That's the only way to do it, by the way. So what I'm going to do is this little section, let's call this section A. Then from here, actually I better not call it section A because I want to call this boundary A. I'm going to call this boundary B. So the first section, what do we call it? This is basically from x equals 1 to x equals A. The middle one is x equals A to x equals B. And then the third section is from x equals B to x equals 5. Does that make sense?
So A is the point of intersection?
Yeah, A is this point of intersection. It's pretty close to 1, but it's a little bit past. We need our calculator to find those. Grab a calculator. Talk me through how to find those.
You do the, FN9T.
That's to find the area.
Oh,
How do you find the intersections?
you have to
What
plug
menu
those
first
into
of
the
all?
Y equals screen, and then graph it, and then,
Yeah, plug these into the Y equals screen if you haven't already. So if you haven't, go ahead and type those in. And then, how do you find the intersections? What menu gives these to you?
second, the trace. button.
Second trace, so you go to the calc menu, and then talk me through it. Where do I go?
You go to, intersection.
Intersection, okay.
And then you
Got
gotta
it.
press it, and then you just.
Yeah,
press,
it'll say first curve, second curve. You can pretty much just hit enter, enter.
And then go to one of the intersections.
Right. For A, I'd like to go to this first intersection. I just hit enter. You go ahead and hit enter. What decimal do you get, roughly?
1.1771.
Yeah, 1.1771. Now, the reason I don't round it to 4 decimal places, there's a rule in math. When do you round off in a math problem? You know? if you have like 10 steps in your math problem, during what steps should you round off?
At the end.
At the very end. Why don't you round off in steps 2, 3, 5, 7?
Well, it's not an exact answer, so
Right.
there's a chance it could, no,
Right, exactly. Let's just say, this is the example I use. Let's just say y'all hire me to shovel your driveway. I drew not, but let's just assume it's true. And, or actually, other way around. I'm hiring you to shovel my driveway. All of you, I'm going to pay you $14.99 an hour to shovel my driveway. And it's not that huge of a driveway, though. But I also want you to shovel the sidewalks and, we've got a huge sidewalk thingy, that's why I was on board. But I digress. So if you want to earn, let's just say you want to, you work 4 hours, because it's huge, heavy snow, it's all icy, you're chiseling away at it and everything, you're working like absolute crazy. So, $14.49 an hour, which is still respectable. $14.49 an hour for 4 hours. And then you come all sweaty and hot and shivering at the same time, and say, okay, Mr. Cog, we finally just, can you please pay us? Absolutely. All right, so here, let me do some math here. So $14.49, just for easy figuring, let me round that. $14.49 rounds down to 14. And 14 actually isn't halfway, so I'm going to round that down to 10. And 4 hours actually is not halfway, so I'm rounding that down to 0. So, have a nice day. Slam. But in other words, if you round and then round and then round, your answer could be a disaster by the time you're done. Like if you round something even to 4 decimal places, and then they ask you to square it, the error is going to multiply a lot. And then if you do more stuff to it, and then take that and divide by 5 and round it off again. And then you take that to the 4th power, I don't even want to see this anymore. This thing is going to have almost no bearing on the real answer. The only time you round off is at the very, very end of a problem, if then. If you have an exact answer, great, that's the best. But if you don't, I want this entire decimal, in other words. And, oops, I just hit quit. Where is it?
there you go.
It acts, yeah, it's stored there. And by the way, some people said, I just want to write down all the decimals on the screen. You could. Just be aware that the calculator stores about 2 or 3 extra decimal places that you cannot see. I'll give you a demo of that in a minute. But for right now, I need to store this. Tell me how.
Press store.
Store?
Whatever letter you want.
Yeah, in this case, I'll do alpha A. Go ahead and store that in A. 1.1771, blah, 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 blah. Okay, so find B using the same technique.
Go back to the graph,
Okay,
second, calc menu.
calc,
Intersection.
okay.
Enter.
First curve, second curve, enter, enter.
And then you go to the second intersection.
Scoot over, crawl your little spider over to the second. Enter, I got this. B is the front. What did y'all get?
8.8228.
Yeah, 8228, 7, 5, 7, yada, yada, yada. I would like, oops, I just quit out of it. By the way, you do that deliberately. Store that into letter B. Got it. Can somebody set this problem up for me? Now remember, this is Y1. The upside down one is Y2. How many pieces am I going to have to do? 3. Little snippet, middle snippet, and a big end snippet. But can you tell me, how would you get the area correctly here? If you do them separately, you can just switch the order and make it work. Which one is higher up in the first teeny snippet? Y1, the upper parabola. So it's going to be the integral from what to what, first of all? From 1 to A of what minus what? Y1 minus Y2 dx. That'll be your first piece. That's this. Then you add that to the next one. What's that going to be? Integral from A to B of what? Right, because y2 is on top this time. y2 minus y1 dx, and then what?
And then, the third one,
Yeah, what do I put here?
plus,
Plus, and then from what to what?
is 5,
From b to 5 of what?
y1 minus y2.
Exactly. y1 minus y2 dx. Go ahead and type that in, and you can do it all in one big string if you want. It looks scary. Do math 9, and then type in your stuff. In y1 and y2, you can just use those if you want to call them up. So I'm going to call this up variables, y variables function y1 minus variables, y variables function y2. So I've got y1 minus y2, comma, x, comma, 1, comma, a, close parentheses, or in your case, just screwed out on, after the dx. Then hit plus, and then do math 9 again. Do the next one. y2 minus y1 minus y1, comma, x, comma, a, comma, b. Close parentheses are screwed after the dx. Plus one more time. Math 9 one more time. This thing. y1 minus y2 minus y2, comma, x, comma, b, comma, 5. Close parentheses. Let it calculate for a bit. Tell me what you get.
7.35.
Correct. Your final answer, I'd like you to round to 4 decimal places, and you should get 11.0135. It is the case that a lot of people start getting off in their answers here, and the reason for that is that they rounded in the intermediate steps. I would recommend you not do that. Does that make sense? All right. You have 4 problems.
Are they like these?
They are. And not all of them overlap. So graph them on your calculator first and see what it looks like. Some of them overlap, some of them do not. If they overlap, then just cut it into pieces. If you don't, then just do a plain old integral and you're done. Does that make sense? Number 3, that is a alternate universe problem. Feel free to switch it if you like. Go for it. Tell me if we get stuck, otherwise, got a good 14 minutes. All right, for people listening at home, I will email this to you post haste. God bless whatever you're doing, and see you soon. Signing off.